Hi Geometry, this is the video for 11.3a. We're just going to do pyramids in this video and cones later on. So today students will be able to find the surface area of a pyramid. So just like any other shape, to find the surface area, you find the area of all the surfaces. So a pyramid is made up of one shape called the base and then all the lateral sides. All the lateral sides are just going to be a triangle. The base can be any shape. So for this one, right here, the base is a hexagon. So we would call this a hexagonal pyramid, okay, named by the shape of its base. Okay, the bottom is a hexagon like that. All the other sides are triangles. That's different from prisms. Prisms had two bases, so they would have this, it would have two hexagons, and then all the lateral sides would be rectangles. Now they're triangles, which is going to change our LA formula just a bit. There's two different kinds of heights of a pyramid, okay, and one of them you want and one of them you don't want. So it does matter which height they give you. The altitude of a pyramid is inside the shape, okay? It's how tall it is if you're standing in the pyramid and you're looking straight up at the top. The top part is called the vertex. So it's from the vertex straight down to the middle of the square at the bottom. That's great if you're looking for volume, but the one that we want is this slant height, okay? And if you can't read it, the abbreviation for it is a cursive L, because the slant height is the height of one of the lateral sides, so that's where the L comes from. It's the lateral height. It's the height of one of the triangles. This is the one that we want today, okay? We want the L, okay? We want the slant height. We don't want just the regular old height until we're doing volume, and then we're going to change our mind. But for right now, we want not the height from the vertex straight down, but we want the height of one of the triangles. If you have the height of one of the triangles, that will be the height of all of the triangles. Okay? Don't worry about the part that says in this book because you don't have a book. All right, so moving on. Here are the formulas we're going to use for the lateral and surface areas of a pyramid. Okay, comparing that to a prism. Okay, for a prism, our lateral area was the perimeter of the base times the height, because all the sides of a prism were rectangles. Now, the lateral area of a pyramid is 1/2 perimeter times kind of a height, the slant height, because each triangle has a base and the same exact slant height. So we can get the perimeter of the base, which is usually the bottom, and multiply by the slant height, but we have to do times 1/2 now because these are actually triangles, and the area formula for a triangle is 1/2 base times height. So it's similar to prism, but instead of H, we're using L, the slanted height, the height of a triangle. And then we have a 1/2 in front because all the sides are triangles. Okay, again, prisms had the surface area formula of LA plus 2B. Well, this one is LA plus B. Why is there not a 2 in front of the B? Well, because there's only one base. So you're not doubling B if there's not two bases. So I like this formula even better. Instead of LA, we know what LA is. 1/2 PL plus the area of the base. Remember, capital B could be any of your formulas. Could be a square on the bottom, could be a triangle on the bottom, could be a pentagon on the bottom. It just depends on what you see. Whatever you see, that's what formula you use to get capital B. All right, we have the formulas. Let's try some with the formula here. So if I can get rid of this, there we go. What is the surface area of the hexagonal pyramid? Okay, so we know that there's a hexagon on the bottom and then a bunch of triangles all around. So first thing we want to look at is, what we need to do is get LA and B and add them together. So for LA, that's 1/2 the perimeter of the base times the slanted height. So we know that this side length here is 6. That means that there's 6 sides that are 6 each. So for the perimeter, we can just do 6 times 6 and use 36. So the perimeter is 36. Okay. L stands for lateral or slanted height. So as long as we have the correct height, we're good to go here. We'll have one in a minute where we don't have the right height. Okay, but this is talking about the height of one of the triangles, which we have right here. 9 is the lateral height right there. Okay, so we're doing 1/2 times 36 times 9 is really what we're doing. Okay, so the lateral area, if you multiply those up, is just going to be 162 square inches. So this is our lateral area. Okay, we need to get the area of the base. Okay, how do you do it? Well, it depends on what shape the base is. Since it's a hexagon, we're going to use 1/2 ASN. A stands for apothem, and they gave us that right here. Okay, that's the distance from the center of the hexagon straight down to the middle of one of the sides. So that's 3 square root of 3. S was 6, and N is talking about the number of sides, which is also 6. So for that, we have what we need. We just have to do the math for it. So we have 1/2 times 3 square root of 3 times 6 times 6. If you can't tell, I'm punching it in right now. And we're getting 93.53 square inches. That's our capital B. So what we need to do is just put those answers together. Okay, so our surface area is LA plus B, which is 162 plus 93.53. Did they tell us how to round? No, they didn't. So we're just going to go nearest tenth. This is about 255. Let me fix my board real quick. I'm going to hit pause. Let's see, 0.5 square inches. Okay. All right, let's try a square pyramid. So capital B is going to change now. Okay, and again, we just have to make sure we have the right kind of height. Looks like we're okay, and we do. Okay, surface area, okay, of a pyramid. LA plus B. So we have to get LA, and we have to get B, and we have to add them together. To get LA, we need the 1/2 of the perimeter times the slanted height. Okay, if one side of a square is 5, then they're all 5. So this is the perimeter is 5 times 4. So the perimeter is 20, and then the L is given to us right here. This is the height of one of the triangles. That's what L is. So L is 6. So for LA, we're doing 1/2 times 20 times 6, which is like 10 times 6. So this is 60. So LA is 60 square meters. We have that. Okay, then we got to get B. Capital B depends on what the bottom shape is, the base shape is. It's a square. If one side is 5, they're all 5. So we have 5 times 5, base times height. So we have 25 square meters for capital B. Those are the two pieces that we need for our final answer. Okay, surface area is LA plus B, which is 60 plus 25. So we have 85 as our answer, square meters. Moving on. So starting to have ones like this, excuse me, where we don't know the correct height. So that's, if you look at this picture, they gave us that 36.4. That's not L. That's actually H. So we're going to have to look at how that changes the problem. So we're going to find the LA and the SA of the pyramid. Okay, we run into a problem right away with lateral area because we can get the perimeter. The perimeter of that square is going to be 30 times 4. So the perimeter is going to be 30 times 4, so 120. Okay, so 1/2 times 120 times, we got to figure out what L is. Okay, they did not give us L. L is right here on the picture, the height of this triangle. We don't have that. Okay, we have the inside height, which is H. This is H. You can't get surface area with H. That's the wrong kind of height. So we have to solve for L, okay, using our Pythagorean theorem. So We have a triangle here. This is 36.4. Okay, this right here is 15. The whole base is 30, and we know that C is right in the center, so we know that it's half of 30. So we're going to use Pythagorean theorem. 15 squared plus 36.4 squared will equal L squared. Okay, L is going to be the hypotenuse every time. That part is going to be nice. But we're going to have 225. 36.4 squared, let's just go to the calculator for 1324.96 equal to L squared. We need to add 225 to that. 1549.96 equal to L squared, and we need to take the square root of both sides. Okay, so if you do that, looks like L is 39 point, let's call it 37. Okay, so 39.37 is what I need to put in for L. I'm going to give myself more space for that. And at that point, I'm going to be able to then do 1/2 times 120 times 39.37 and get my LA of 2,362.2. That's LA. That's one of the answers because they're asking for LA and SA. So to get SA, I just need to also get capital B. Okay, the bottom is a square. So I know that if one side is 30, they're all 30. So 30 times 30 will give me capital B, which is 900 square meters. So I forgot square meters over here for my unit. Okay, so then if I wanted to get the surface area, I'm just going to add those together. So 2362.2 plus 900. And we're already going to be in nearest tenth, so we're going to be in great shape. 3262.2 square meters. And that's going to be it. So if you have the wrong height, the way to fix it is use Pythagorean theorem. Find that slanted height, which is always going to be your hypotenuse. So there's one more hexagon one that you might have noticed I deleted off of the board here because it's going to be very similar where you have the wrong kind of height. So that's going to be it for the first part, and today is going to have a worksheet as an assignment, no Schoology part. Thanks for watching. Have a great day.